Okay, okay. Hey, how are you? So, if you need any help while I'm giving classes, that's your man, right here. He can, yeah, him. There you go. Cool. So everybody's in. I want everybody to go to PyCharm. I'm gonna just wait real quick for the people that just installed PyCharm.
There's no on button.
No, we were looking for one. Because I need to turn on to. I know the guy.
Wait, is this one?
So I just left you. So here's the spring semester. No, so it I'm not really sure what I didn't, I just opened it, but
Oh, you have candy?
No.
Code everything by hand. That's literally, I like the green flavor.
Oh, really? I ate all of those.
Wait, really? Wait, how do you code by hand on the test?
Yep.
Oh, no, alright, so what, alright, I'm in 201. So for the exam, you code by hand? Yeah.
Okay, people, we're gonna start.
Yeah, you could
With
like the open-ended ones or by hand.
You guys need like I'm at less math like in the lab.
Like 2 weeks.
My lab is
He
not
said
hard
he couldn't
at
fix
all.
it.
Okay,
I'm taking
Yeah,
just
I'll
that's just all math lab.
I'll listen for now.
yeah, you can sit wherever you want.
What?
In the front of class?
Yeah, sure.
Wait, we're just gonna interrupt the camera?
Okay, you please.
Okay.
Cool. Okay, so everybody, attention now. We're starting. So we're gonna create a new project, and now we're actually gonna call it. Give me a second. We're gonna call it Python classes, and that's it. That's gonna be our project. The first one we already created, like class 0. That was just to get everybody acquainted with PyCharm. Now let's go here, right click. We're gonna do new Python file. We're gonna do class 1. This is actually the real class. So I'm gonna do a quick review while everybody gets, so you know this is how you do a comment, right? And then I'm gonna review the math stuff that we did. So basic math, right? We did plus, right? And then we did subtraction, that's very basic, multiplication, right? And then we get into division, right? And then we have, this is with fraction, right? So with fraction. And then this is integer division. So instead of giving us 2.5, it will give us a 2. So this is integer division. And then we also saw this, which is exponentiation. So it will be 25, right? So exponentiation. I think that's how it called. You know, squaring, blah, blah, blah. Exponentiation. Okay, cool. And then we saw the concept of a variable, right? So variables. What's a variable? Anybody can tell me? Yes.
It's like something that's value can change.
Correct. So something that a value can change. A value changing element to store data. So there's some syntax of variables. I didn't talk to you about this yesterday on Monday because I didn't want to overwhelm you. So the first one, it has to start with letter or underscore. That's how it has to start the variable. So syntax of variable name. After that, you can do whatever you want. So you can call it, hello. You cannot start with a number because the IDE thinks it's something else. Okay, you always gotta start with a letter or an underscore. So why we have variables? To store values. So we have my name, and then we saw what is a string. So a string. So I'm gonna put like Alejandro. This is like a list of characters, right? That's a string. So consecutive characters. Consecutive, okay, characters. Cool. What else do we see? We saw numbers, right? Just numbers, and then this is a floating point. It's something that is a number that has a decimal part, right? And is you write a floating point. That all we saw last time. So now also we saw a set. So I'm gonna call it my set. And it's a place to store elements. It can be anything, and you cannot eliminate elements. So it's read only. Eliminate or add elements, right? That all we saw last time. And then my list, right? So it starts like this. You can put more elements, and then you can update elements in the list so it can grow and shrink. And last thing we saw, it's a dictionary. So my dictionary, right? And this is the syntax. You put it in brackets, sorry. This has a key element factor. So it's key value factor. So this is useful for storing. For example, you put something like in a string, your age, and then you put 25. I'm not 25, but I don't want to give personal data. No, I'm kidding. Then you can put your name, and then you can put Alejandro, right? What else? Favorite color. So you put color, and then you can put, oh, what's that? You can put blue. Cool. So those are the things that we saw last time. Yes.
You don't have to declare a data type.
You do not have to declare data type. The moment you assign, which you put the equal sign here, the moment you assign the interpreter, which is the little thing running behind Python that allows you to understand whatever you're writing, predicts what you're gonna write. So if you put the brackets, it already knows that it's a dictionary. So you don't have to tell them. In other languages like C, Java, C++, you do have to implicitly tell, hey, I have an integer here and I want to create an integer. Python, no. Python is simple, straightforward. You just put whatever variable you want. Now, I'm going to show you one of the most important stuff, and this is actually the beginning of this class. So when you have computers are dumb. They only execute whatever you want to do. And then there's this concept of true and false. So we're going to actually make a variable. So my decision, right? And then we can make it true. And then you can also make it my decision. Then you can make it false, right? So why do we do this? Computers execute things sequentially. And sometimes you write a program, like let's say a zombie application, right? So you are here and you're like killing zombies, and then you shoot them in the head, they die. So if shoot in the head, die, right? So you gotta have that way of, like, this is for a game, right? Let's make another program, like less bloody. If you click accept, then open a window, things like that. So that's called execution control. Allows you to bring paths and more things into your program. And then you have to have the concept of true and false. And then now we're gonna see if, and then else, and elif statements. Okay, so the first thing, if my decision, then what do? We can say print. Remember when we use print? So print allows you to show things in the screen once we run the program. Print hello, right? Right now my decision is false, right? There's also something that you need to know. Now that we're getting in sequences, you need to know that code runs from top to bottom. So it's sequentially, like it goes like this. So for example, I have this variable called my decision, and it equals to true at the beginning. Now here it equals to false. So actually at the end, when I'm here, my decision is gonna have what value? True or false? False, correct. So basically it's the last thing that you did in your code. That's what gets executed. So let's see if I execute this baby, what's gonna happen. Nothing happens, right? Because it was false. Now let's make my decision true. My decision equals to true. So what's gonna happen? Boom, hello. There you go. So we actually branch into the main execution of the program. Now sometimes, let's see real examples in life. I don't know, let me think about this for a second. Here, let's make a real, I don't know, student example. She likes me, right? False. If she likes me, right, I'm gonna print I am going to ask for her number, right? Cool. Now I don't want to give up that easy. If she doesn't like me, what? You just don't ask for her number. Well, and then you can put else, right? So this is something that, well, let's go elif. Right, elif, it means else if. So if the first one didn't get executed, you check the second one. So she is interested. Maybe that's true. She's maybe interested in me. She doesn't like me, but she is interested in me, right? If she's interested, print, I'm gonna ask her how you doing, right? Else, I'm just going to cry, right? Because I get sad. So what do you think is gonna get executed in this? The cry, the how you doing, or the I'm going to ask for her number? Based on these two variables that we just saw. How you doing? There you go. So let's check it out. How you doing? Cool. So that's very useful. And then you actually saw in a very simple way how if, elif statement, and else are used. Now else, you don't necessarily have to put it, like for example, if I take the else away and I just hit this print here, it's just gonna print how you doing and then cry, right? So that's the difference between putting an else and not putting an else. Now there's something else that I wanna make you realize here. Do you see every time that I put this type of if statements, I put these two dots and then there's this spacing in between? So that spacing in between means you put the if statement and then whatever gets executed in this tab part is whatever it's inside. So this is inside this if statement. So inside this if statement, and this is the outside of the if statement. So think about it of this, like you begin here. If you hit this, it branches here in this tab part. And if not, you keep going to this side. So this is like literally the computer will come here, hits the statement. If it's false, it just continues here. But if it's true, it will come here and then it will execute this and then it will come back here. So that's how Python does it. In other languages, like C, you have brackets, right? I just wanted to show you, and then it shows that if this gets executed, all in between these brackets are gonna get executed. That's just for your common knowledge, to show you that Python doesn't require you to put annoying brackets all the time, but it works based on the spacing that you have. So you have your if statement, and then you make a tab space for the orders that you want to execute if that if statement gets hit. So yeah, and that's the syntax. You put this if statement. So you have the if statement, and then you have something that is true or false, right? I'm gonna give you now a ugly word, which is the technical word for true and false. It's called Boolean. Okay, so a Boolean is a true or false element. And then computer scientists learn this all about Boolean algebra and how to simplify Boolean algebra, but in few words, it's just either true or false. And now we're gonna get into something even more mind-blowing. What is true and what is false? Well, computers, yes. Well, that's a very like metaphorical question. What is true and what is false? But computers see everything as ones and zeros. So true is 1 and false is 0. True is on and false is off. So this is the most basic element of computing. Trues and false. With that said, do you have any questions about this? You can, yes.
So how do you know so when you're like finishing your else or your if statement, how do you like go to the next line of code without it being in the statement?
So then you go back. You see this print statement is here. If I take this print statement here, that's where it's no longer there anymore. So that's gonna actually execute regardless of whether she likes me or not. Let's see this. Oh wait.
So the tabbing.
The problem here is that the elif, it gets connected with the if, so we actually need to get rid of these things too. So it's gonna print regardless of. Let me see what's happening here. Oh yeah. So it's telling me, hey, you put an if statement there. Are you gonna just don't do anything? So I'm just gonna hit pass. So if something happens, I'm just gonna pass, right? That's another keyword. Hello, I'm going to ask for her number, right? Because it's outside the if statement. Now, if it's inside the if statement, it's gonna actually evaluate if she likes. So she doesn't like me, obviously. So I can ask for her number. Cool. There you go. So I'm just gonna go back to all this that we did. Any other questions? No?
You scroll up for you scroll up really quickly.
Yes. Wait, let me bring this a little lower so you can see everything. Cool. So then you can use if statements and else statements basically to, for example, another example, order input. So if the person wants to add a value or subtract a value, and then you can make menus based on this. If the person chooses this task instead of this other task, you execute certain parts of code and other parts of code. And with that said, I'm gonna bring you to a new concept, which is called loops. Loops. I'm going a little fast, but know that I'm gonna review all this every single class, so it gets into your brain. You know, I'm just gonna repeat it until you get tired of it, but also it gets in your mind and you actually learn. So what is a loop? Anyone wanna tell me? In general words, yes. Yeah, something circular, something that keeps happening and happening and happening. You're in the loop. It's just like something that keeps happening, right? Now, you don't want anything to happen forever, so that's why you use if statements, true and false, to make sure that some situation stops happening and it doesn't go forever. So there's two types of main loops that Python uses. The while loop, so you use while, and here you put a condition. So condition, and then you put this thing, same thing, and then something gets executed, right? And this is your code to execute in while loop, right? So we're gonna review this while loop for right now. And I'm gonna create a small variable, so I'm gonna call it my number, right? You don't have to call everything my number. Once you start doing real applications, you're never gonna call something my number or my value or whatever. it's gonna have a real meaning, so like user input or something. But for right now, let's put my number equals to 1. So we're gonna do while my number, and this is where the boolean, you know what I talked to you about, boolean stuff comes in play. So how you know things happen, you can use your basic math. So while my number is less than or equal to 10, right? I'm gonna give you all the possibilities that you can use with Boolean algebra to execute. I'm gonna print my number, okay? And then if I execute this just as is, my number is always gonna be 1. So if I literally execute this, you will see what happens. It just keeps throwing ones, right? It's never gonna end, right? Because the loop just keeps going and keeps going, and every time this gets executed, it's gonna go back up here, check if my number is less than 10, and then come back and print it, and then go back, check if my number is less than 10, and keep printing it. So this is gonna run forever. In reality, people are scared of infinite loops because they crash your computer, but your computer is actually using an infinite loop all the time to get your input. So there's something, a clock running in your computer every single time, updating and updating and updating until you do something in your computer and then execute. And I'm gonna stop this. It's not gonna crash my computer just because it's Python, so it makes sure that it doesn't get all your resources. But other languages, it will literally take all your RAM, it will take all your memory until like your computer crashes. Anyway, so I'm gonna do my number, and we're gonna use the basic math that we learned last time. So plus equal to 1, which, anyone wanna tell me what that mean or that meant? Yes.
Like every time you input, so it's basically like shortened version of like if my number equals to my number plus 1.
Correct. My number equals my number plus 1. That's the meaning of that. And you can do that with minus, with multiplication and division. You put whatever you want to do, the arithmetic operator here, and then the equal sign. Cool. Let's see what happens if we do this. It counts from 1 to 10. We got it. So it counts from 1 to 10. Now, I'm going to make a little parenthesis in the while loop information here, so let you know what things you can use to compare, comparison stuff. So you can use less than or equal. You can also use less than. You can use greater than or equal. You can use equal. So if my thing equals to 10, that also works, you see. Oh, you see it didn't run. Why it didn't run? Anyone want to tell me why it didn't run? Because I literally just said that's 1 equal to 10. And that's false, so it never ran, right? So that's the equal sign. You will make it less than or equal, it's gonna count to 10. Now it's saying is 1 less than or equal to 10. That's the first iteration it does. Here my number is gonna go to 2. So then it's 2 less than or equal to 10. And then in the next one it's gonna be 3, right? And then 3 is that less than or equal to 10. And it goes on and on and on until 10 is more, like my number is more than 10, and it stops. So it's when it hits 11. And actually you gotta be really careful about this because we have some prizes that we're gonna win, and we're gonna make a little contest based on loops. And I'm gonna also show you why computers are so important. Because yes. No, yeah, you can definitely do while loops. I personally use for loops all the time because I go through lists that have a certain amount of elements that you know all the time. You gotta be deterministic in like programming. You don't wanna like base yourself in like, that's why like, you know, programmers, they think binary, they think either yes or no logic. You don't wanna have something that never gonna happen or have doubts. You want your program to lay down really clean and complete so you don't have errors. So even the person tries to do the crazy stuff with your program, it won't break your program, or it won't hack your program, or there's bugs. So yeah. But yeah, while loops are perfectly acceptable. They're not bad at all. They're used for certain things where comparisons and truthfulness is important and you want to keep going. I'm going to give you an example. If I want the user to input a number and the user keeps and the user keeps putting a string instead of a number, I can put him in a loop that keeps asking and asking and asking and asking. That's a great example where you can use while loops. So it's not gonna stop asking until you actually put a number, and it's gonna be infinite unless you put a number instead of a string. Examples like that. Cool. Any other questions? I have one more here that I want to show you. So this is like that. That means not equal. I'm going to put in the important ones. So this one is equal, right? Equal. So we can do that. While my number is not equal to 10, what do you think it's going to be? Is it going to count from 1 to 10 again? It's only going to count from 1 to 9 because 10 not equal to 10, they actually equal, so it's going to stop right there, right before you can print the 10. Cool. And then the next one, I'm not going to show you yet. It's a little more powerful, but I want you to have a little more understanding of lists before we do for loops. And we're going to bring the contest now because already 6:40. So, this is the contest. I want you to add all the numbers. Let's make it more spicy. All the odd numbers from 1 to 1,000. No, actually, let's make it more spicy because we're using computers. To 5,000 and give me the result. And just print it there. So, how will you do it? Modulus? Correct. That's true. We're gonna show you one key factor here. Good job, my man. That's why you're my man. So we have plus, we saw plus sign, minus, right? Division, multiplication, integer division, exponentiation. We're gonna see one more that they actually need for this because I decided to do the odd numbers. This is called modulus. Modulus. I know there's music going on. I just wanted to spice it a little bit there. No, it's a Latin Python class, right? So we have to have some music, right? So modulus, what modulus does? Anybody wants to tell me what modulus does? We're going to define modulus. Yes?
I think, doesn't it find the remainder?
Correct. You get a chocolate later. It finds the remainder of a division. So let's do 5 modulus 2. What is it going to give you? What is it going to give you? This is going to be under parentheses because this is actually not coding. I just want to see if you know what is happening. So 5 divided by 2. What is it? You got to divide 5 by 2. So let's see if I can take chalk. This is also a very visual thing. So remember, you have a 5, you divide thing by 2, then you say 2, you do this, and then you multiply 4, and gives you 1, right? There you go, that's modulus. It gives you the remainder of the integer division. That's it. Everybody is weirded out of my division way, right? Yeah. Okay, so I was just making it very graphical. So you multiply this by this, you subtract this, right? And then you have that. Any American person wants to come and do a division here because that was like the Ecuadorian way of dividing, I guess. Anyway, it gives you the remainder. What is this useful? Why he said we need this for the odd, right? I'm gonna give you a little, how you say when you help, a little help for your task. So you have 6 modulus 2, right? What is the result? 0, correct. So 8 modulus 2. What's the result? 0. So it's only going to give you 1 if it's an odd number, right? If modulus of the number equals to 1, you add it to your value, right? I'm going to give you a starter code, so it's not as hard, okay? We're going to start by using our concept of variables. So we're going to make sum equals to what? We're gonna initialize it to 0. Then we're gonna have a while loop, right? We don't know what's our while loop, so we need like a counter, right? We're gonna make it 0 as well. I'm gonna start you guys with this because it's gonna be a little, I don't know if it's gonna be too hard or not. So I'm just gonna make it easy, and then if everybody gets it, I'll make it a little more difficult. So if counter is what? Is less than or is not equal to, well, let's do less than or equal to what? To 5,000, right? So our loop is gonna run for 5,000 times, right? Actually, it's gonna run for a little more. It's gonna be 5,001. Why? Because the beginning is 0. So if you want it to run for 5,000 times, you either make this one 1, or you just do less than 5,000. Okay? Either or, doesn't really matter. Now, if you say, I want you all the add up from 1 to 5,000, what's better to do? We can make our counter to 1, right? And then we do less than or equal. Perfect. Now there's something happening here. I'm not gonna tell you what's happening, but it's based on what the modulus we just saw. And then you're gonna do sum, and you're gonna do something to sum. And after this while loop, you're gonna print me your sum. That's your starter code. And then you have 5 minutes. Go.
I have no.
Oh, okay. So if statement, you do he likes, right? So what's he likes? He likes is false. So this is not gonna exist. Elif means else if. So if the first one didn't happen, you check here. And that's why it's else. So if this didn't happen, you do else. But it also has an if statement. So else with a condition, which is he is interested. Oh, you put he instead of she. That's cool. That's cool. I like it. True. So if this is true, then this is gonna get executed. So what made it true? We just said true here. We initialize it to true. That's why it made it true. And this is the body of your if statement. The thing that comes in tabs. That's the body. So that's what gets executed if this condition is true. Okay. I'm gonna turn on the you already have it? Okay. I haven't come here. You can get in the queue. I haven't checked that out, so I'm gonna turn the computer in blank to calculate the thing.
Alright,
So I know what's the result.
I got this one.
Okay. Let me take a picture of it so I know what's it after.
Alright.
Let's see. Boom. Cool. Remember to update your counter, otherwise your computer will get in a infinite loop. So let me see. Your counter gets updated. Remember when we were updating from 1 to 10? That it gets adding 1 to the counter. Make sure you add 1 to the counter in the loop, otherwise it's never gonna arrive to a 5,000. It's gonna stay in 1, 1, 1, 1, 1, 1. For some reason, your input is wrong. Can you come see me? Your output, sorry, not your input.
I think I'm off. Let me.
You're off by you're off by a little bit, not as much. You're actually off by a lot. No, you're not off by a lot. Let me see. Just by a little bit. Cool. So you see, imagine trying to do this in a calculator, how long it will take you. You will have to add 5,000 numbers. In a computer is in 1 second. Now that shows how powerful computers can be. And this is just the basic thing you can do with a computer. I'm gonna show you way more powerful stuff later. Okay, I'm gonna give you 10 minutes actually, so you are already in 7 minutes. We're gonna have 3 more minutes. And I'm gonna show a more hint because I want somebody to win. How do you, let's see.
You said I was off by a little bit.
All by a little bit, yes.
How little is little?
Like 5,000. Or 50,000, I don't know. No, just 5,000. So, I'm gonna do like a little more insights. The question marks are where you should put something. So counter modulus of what is gonna be equal to what in order to execute what. I'm gonna do this last key here. Sum has to, you have to add something to sum. Oh my god. Sorry for that. Plus equal, you have to add something to sum. What is it gonna be? What is the other variable playing here? So you're gonna add that here too. And that's it. And you can just, oh my god. I already show you the okay, things change. We're actually gonna do it to 9,000. Doesn't really matter. Just change your 5 to 9. It's the same process, you see. Because I already showed you what's the result, so you're just gonna come and be like, oh, that's the result. We're gonna do 9,000. You gotta fill in the blank. When I used to learn English, there was like a fill in the blank. So this parenthesis is going to give you a number that you're going to check if it's equal to another number. And if that happens, then you're going to add some number to sum. And this plus equals just means whatever we saw last time. My number plus 1, right? My number gets stored my number plus 1. So it keeps adding into it, right? So if counter modulus, remember what was the modulus? So if modulus gives us 0, it's an even number. If modulus gives us 1, it's another number. So basically you have to think whether it's going to be odd or even. What number are you going to put here? You're going to put a 1 or a 0. Do you already have it? Anyone has it? Is everybody lost?
I'm lost.
Okay. I'm going to give you one more hint here. Counter modulus of 2, remember? That was the one that gives us 0 or 1. Right? So if it's odd, what gives us? If it's odd, gives us a 2? No.
Give one.
It gives us 1, yes. So what are you going to fill in the blank here? Correct. So basically here we're saying if odd, right? We simplify it into that. You got it? Okay, I haven't done it yet, but let me put in the blank the thing. Yes, you got it. We have our first winner. You have, what do you want, M&M's or whatever, I don't know what's that. M&M's. Red, yellow, or brown? Yellow. Here, have 2. You're the first one. Hey, good catch. Anyone else? What? You have code but won't run? 0.
There's like something on download. Like it won't run no matter what.
Okay, so we are down to one thing that you need to fill in the blank to get a chocolate. What is that one thing? 9,000. No, if it's 9,000, you will be adding 9,000 every time you hit an odd number. Now you know? there's only one thing that is changing as well. What is the other thing that is changing? If we just get in here, what are the two names that I have? I have sum and I have counter. What are you gonna fill in the blank with? You got it. Wait, let me see. What was your number? I don't remember. Yes, you got it. What do you want? 2 more minutes, guys. You think you got it? Yes, correct. Good job, man. I'm glad that people are getting it. That means that this is working. Come get your prize, whatever you want. Anyone else?
Ooh. Like I was saying, it's this is done that, but I never took code. I never even seen code.
I mean, hey, like you should have the so like the counter, right? It starts out one. By saying 1 divided by 2. You get a reminder of 1, right? So that means it's true. So when you sum it,
He said it's true.
yeah, because it's 1 is odd. I guess then you add, you sum it with that number.
Yeah,
so like
you got it.
Plus
Bang.
is like sum.
Okay, anyone else? We're closing in 2 minutes.
Because it is all.
Anyone else? What are you gonna put in there? Fill in the blank.
So actually, your program is still running.
What?
So they kind of just leave it and watch code.
No, you cannot.
Checks it. Even checks it off.
You want
But then you're.
I didn't change it.
Yeah, it doesn't. Okay, now it's
You get
well, you can use it.
You don't have the sum.
No, that's what's Yeah, that's what I'm saying. So we both did.
So you have everything.
So the number is
It's not a thing. It's a little
And then it checks if there's remainder. And then instead it's going until like where
The answer?
counter is less than or equal to 9,000.
You want me to give you the answer? Oh, you want to check the answer?
I don't know. It's like it's some
Yes.
long ass thing.
Oh, wait.
You got it. Yeah, you got it. You got it. Cool. Come get your candies. Okay, guys, I'm gonna show you. So the thing that comes here is counter. Now, some of you did different code than others. That doesn't mean it's wrong. There was other ways to do it. There's actually several ways to do this problem. Yes,
I did it.
you did it.
It's
It's easy to
I
say.
did it.
Okay, cool. Good job. Well, I'm gonna tell you what's happening now, so people understand it. Here, have some chocolate. Well, you got your chocolates. Cool. So, here, let's go. What's happening here? A good way to understanding loops is actually going every single iteration until you get the feeling of what's happening. So here it starts at 1 and compares. If 1 is less than 1,000, it says, yeah, is 1 less or equal to 1,000, 9,000. That's true, right? So it enters in the loop body. If counter modulus 2, so 1 modulus 2, what's 1 modulus 2? The remainder of 1 modulus 2 is 1, because you can actually not divide 1 divided by 2, so it's just that 1. So you get here 1 equals to 1. That is actually true. That gets added, so sum becomes 1 right now. And then counter becomes 2. This is a good way of analyzing what's happening in the code. Later on, that's just going to happen naturally in your heads. For right now, it's fine. Now counter is at 2. Is counter less than or equal to 9,000? That is actually true, so we enter in the loop body. And we get 2 modulus 2. What's 2 modulus 2?
0.
0. So is 0 equal to 1? No, that's false. So this doesn't get executed. So sum still equals to 1 in this iteration. We call them iteration in technical terms, but that's bullshit. Don't. I'll teach you the slang later. Slang is not important. It just confuses at the beginning. So counter now is gonna be equal to 3, right? We go up. I'm gonna do one more, so you get the feel of it. 3 less than or equal to 9,000. Is that true or false? Is 3 less than or equal to 1,000? Yes. We enter into the loop body. So 3 modulus 2. What's 3 modulus 2? 1. So is 1 equal to 1? Correct. So we enter here. What's now sum? What's gonna be sum? What's gonna be the value of sum? It was before 1. Now it's gonna be 4. Correct. And now here we go down here and counter actually becomes 4. And then you keep going and you can keep doing this manually until you arrive to 9,000, or you can just write the code and it happens just like that. There you go, guys. That's basically it for today. Thank you so much for coming. We are gonna do more reviews. The people that need questions or need some help, just come see me now and we're good. I'm just gonna keep putting the music up.
Yeah.